So this is part 2 to lesson 18. And this says refer to the graph to solve. So this right here, if you look, the y-intercept is 2 and the slope is down 1, positive 2. So that'd be negative 1 over 2. And you see the slope is this. And then we have this equals 1 here. So what this is you look at it as two separate equations. So this is y equals this, and this is y equals 1. Well, if you remember, Mr. Hoy says that a y equals equation is a horizontal line going through that number. So here is y equals 1. Well, y equals 1 crosses the other equation here, and in that equation, we see that x equals 2. Okay, let's look at the next one. So this one, notice that this is the same, but this time y equals 4. So we're going to come up here at 4, x equals negative 4. This one, y equals negative 1, so we're going to come over here, x equals 6. This one, y equals 0, so that's right here, x equals 4. Yes, it is as easy as that. Okay. Refer to the graph to solve. So, if you see here, this line is y equals this. This line is y equals this. You see they cross right here. So x equals negative 5. So that's solving it graphically. If we wanted to solve it symbolically, we would distribute here first, negative 5 minus x minus 1 minus 5. No, hang on. Parenthesis 5 minus 2x plus 3. And then that gives us negative 5 plus x plus 1. We have to distribute this negative, so minus 5 plus 2x minus 3. Let's clean that up. Negative 4 plus x. 9 minus 5 is 4. Minus 3 is 1 plus 2x. So if I subtract 1, we get negative 5. Subtract x and subtract x, we get 1x. And so we can see x equals negative 5, just like we saw here. If we plugged it back in, we could see numerically that, yes, it's the same on both sides. There it is. Alright, so this one is a different viewpoint, the same thing. It's saying that this is y equals 1. So y equals 1, then x would equal 2. See right here? y equals 10, then x equals 5. Y equals 4, and x equals 3. Okay. This one looks intimidating, but it's just saying this is y. This is y1. Or sorry, this is y1, and this is what x equals. So if y is equal to -2, x was -6. Y is 0 here, then x would be 6. Alright, so this is saying this is y1, and this is y2. And if we see here they are the same, so we know that x equals 1. So let's check that out. 3 times x is 3x. 3 times -1. -2 times 1. -2 times -x is +2x. Let's not get that confused. So we're going to subtract 2x and subtract 2x. That gives us 1x or x. Add 3 and add 3. And that equals 1. So yes, x equals 1. So what you see here is when they're the same, when your y equals are the same, that's when you know what x is going to equal. I'll see how many more there were. 13. Record Broadway ticket revenues were recorded for the 1999 season. These ticket revenues in millions of dollars have grown at a constant rate. That would mean the same rate during the past decade and may be modeled by this. So we see this linear equation. This stands for y, and x is going to be the year. Estimate the ticket revenues in 1995 and in 1999. So we are going to put in 1995. Do the math. I got 456.8. So what that means is in 1995, they estimate the ticket revenue to be $456.8 million. In 1999, $588 million. this one, it's wanting you to estimate the year when the revenue totaled $424 million. So that means we're going to put it in place of f of x. And so that would be 424 equals 32.8x. So we're add and add. And then divide by 32.8. And I get x equal to 1994. So in 1994, the estimate was 424 million. Alright, I'm going to leave the rest of this for you all to do, if this is the paper that you all have. If your paper doesn't have all of these, if you do them, I think it will benefit you. And we will do 14, 15, and 16 in class.